we learned about 4 libraries. We learned about Matplotlib, we learned about Altair, we learned about Plotly, and we learned about Seaborn. Matplotlib is sort of foundational. Seaborn layers upon it with some quite rich functionality. Then we have the top, the bottom. Yeah. And then we have Plotly, which is based upon D3, gives some interesting interactive functionality. Then we have Altair, which is based on Vega Lite, which itself has been layered upon D3 visualizations. So that's quite a rich library, set of visualizations. The world of visualization is very, very rich. And I thought I would start today with one particular graph, which is worth talking about. If you look at the if you look at the landscape, and I'll just go and make this graph bigger. See, there are two, when you look at it as a data scientist, and I'm here excluding R. If you just look at the Python world, at the core of the Python world is Matplotlib. Right? Things that are related to Matplotlib is Altair is indirectly related to Matplotlib, but not. It sort of works well with it, but it's sort of separated from it. It is based on Vega Lite, which is based on Vega, which is based on D3. There has been another effort directly to bridge D3 to Matplotlib, which is the MP LD3 library. What it does, so I'll just give you a general sense. What it does is it says, can you just use Matplotlib itself, but make it interactive by changing the underlying layer and making it use D3. So implicit through all of this is this big sort of a gorilla in the data visualization space, which is D3JS, in the plotting and graphing plots and so forth, which is really very well done. It is, as I said, the grammar of graphics writ large. So there has been a lot of effort, as you can see, within D3. You can find different links going up to Matplotlib and trying to do that. So this is one set of journey. Then when it comes to graph visualization, network visualization, you find that there is NetworkX. NetworkX, which is a core library to deal with networks at the algorithmic layer, to find communities or degree. Do all sorts of interesting stuff with networks, right, or graphs. The visualization support in NetworkX is, should we say, work in progress. It works, but it's not lightning fast. And the layout engine, one of the problems that happens is when you deal with a lot of nodes which are connected to each other through edges, and they're non-planar and so forth, finding a good layout becomes itself a subfield of work. How do you find the best layout of those nodes on a two-dimensional surface, or two dimensions? And one of the layout that has been there, especially in the Linux world, is called GraphViz. Now I believe it's there for all operating systems. GraphViz. So NetworkX sometimes uses GraphViz for its layout. Then you also have GraphTools. GraphTools, and there's many more that has been missed. For example, iGraph has been missed, and so on and so forth. So there are many tools in this space for network visualization. Today, we will be playing with NetworkX, and we will be playing with a little bit of an interactive network visualization called PyViz. Don't confuse it with PyViz. That would be PyViz. That is there. Then there are many, like Seaborn is something we are taking very, very seriously. The ggplot of R, those of you who know ggplot, that has been ported over almost as is into the world of Python, and it is called Plot9. Then, if you're doing machine learning, some of you may be familiar when we did linear regression, all of these things, clustering, this, that. When you build a model, how do you visualize the model itself? Not the data, but the model. So for model visualization, there are two very good libraries. One of them is Yellowbrick. The other one of them is Scikit-Knot. Right? We used, if those of you, if you remember, if you've taken other workshops, you would recall that we have used Yellowbrick extensively. We haven't used Scikit-Plot as much, but it also can be used. Okay? So, and I won't talk about all of them. Of course, Pandas, we all know, Seaborn, we all know. We can talk a lot about many, many libraries that are there in this space. HoloView, we just did one example. Now look at the world of in the JavaScript world. Obviously, there are many libraries which are foundational and that are related to. You see this big line to D3. There, other than that, there are a few pretty important libraries that people have put on top of it. The first thing you notice is Plotly. Plotly is in Python. What it does is it sits upon JavaScript and D3. Uses underneath, it generates JavaScript code that creates D3 code and so on and so forth. There's a Bouquet, and there are some other libraries. We tried Bouquet. I don't know if we tried. No, we didn't do that. There are quite a few other libraries, and I'll talk a little bit about it. Py3.js. What is Py3.js? If you want to do three-dimensional visualization, especially with shadings and color and camera locations and so forth, those of you who are familiar with computer graphics, 3JS is your friend. It uses the full power of OpenGL and WebGL. Now, there is an effort to make it accessible from the Python world. So Py3.js is your friend there. Then there is something called Leaflet. Leaflet is for map visualization. So there is Folium. I don't see it mentioned here. There's Folium, and then there's IPyLeaflet and so forth. So there are many such libraries. I won't go through all of them. But then if you look at the granddaddy of all of them, in the world of data and computer graphics, to the extent, like if you go deeper into visualization, soon you find yourself in the territory of computer graphics. For example, when you do games and animations, you're into computer graphics and so forth, and you're using full graphic engines. Right? You must have heard of video cards claiming that they have support for a physics engine and whatnot, and a scene rendering extremely fast shaders and whatnot. So that's the world that's going pretty deep into that space, and we're getting a little bit far from the pure data visualization. You can actually start from OpenGL itself and visualize the data, but it's almost like for most common situations, you don't want to do it because it's almost like starting with first building the spare parts, assembling them on a bicycle, and then going for a ride. Right? Becomes a bit of an overkill, but sometimes you have to go down and you have to make it possible. So around it, you can see again a whole slew of libraries that leverage OpenGL directly. So, yes.
I don't see the mouse pointer on the Zoom, so maybe you can use some kind of pencil.
Oh, that is right. Zoom gives a pencil support. You're able to see, like here.
On this Zoom computer, you can. I think it's darker there. There's light.
Kind of small.
Right. On the monitor, you can't see, is it? Monitor. Okay. Okay. I'll try to make it bigger. Is that better now? The mouse more visible? Yeah. So this is it.
Setting in Zoom to make the mouse.
Okay. Yeah, that would be a good thing. Actually, I would like to learn that trick also. All right, guys. So for now, this is the landscape. It's a bewildering landscape of lots of libraries. One of the first things that happens is when people come to data visualization in Python, they just get lost. What should we do? And the reaction often is just to stick with Matplotlib, which is very powerful. Now you have to find a middle ground based on what you're doing. So we learned 4 libraries. Of course, Pandas we know. We learned Matplotlib, Seaborn, we learned Plotly, and we learned Altair, which implicitly sits upon Vegas. Now, for networks today, we will learn one more library, NetworkX, and for maps, we'll learn about a library. We'll do maps using a couple of libraries, Plotly and Folium, which sits upon Leaflet. So you will get acquainted with a few more libraries. generally, I would say that take this approach, take Matplotlib as your base, and reach out to other libraries as you see value for your particular visualizations there. Right? So with that there, now I will go back and recap what we did last time. Last time we did.
Question.
Yes.
You mentioned that sometimes you may have to go back to OpenGL and do things under the cover. Right?
Yes.
So, but I don't see a, what you call, connected things from OpenGL into any of these ecosystems. How does that work? What do you mean by going down?
There's a catch to it. This diagram is not quite, I would say, accurate. This 3JS uses WebGL.
Okay.
Which is essentially, and WebGL will be driven at the graphic layer on your operating system by either OpenGL or by DirectX, Windows DirectX.
Oh, I see.
So there is a standard, it's called WebGL for browsers, and they all leverage that. And it is just evocative. You know, when you go to see Google Earth,
right,
and you see these beautiful visualizations popping up and so forth, you see all of those, you see the power of 3D, high performance 3D animations and visualizations. Now you're getting more and more into the territory of direct computer graphics and layering upon it. And if you have ever layered data or visualization upon Google Earth and its APIs, you do realize how very powerful it becomes. Right? So that is it. And so, I mean, see, a workshop like this, which is 2 days, its main purpose is to get you running. But the moment you run, you realize that all you have done is touch the tip of the iceberg, isn't it? Data visualization is essentially a world in itself. The data scientists tend to underestimate it till they get into it. And it is a testament today, people who do good data visualization, frankly, and I'm not exaggerating, I'm saying from the limited experience that I have with some great data visualizers, a typical data scientist will earn in the order of 200 plus minus 100. The typical one, the very good ones will earn $500,000 or something like that. It's a machine learning engineers or 600K or 700K. And the exceptionals will earn 7 figures. In the data visualization world, people who do data visualization very well, they are so few and far between because they need to be mathematical, they need to be engineers, but they need to have a deep sense of art and aesthetics. And to have this dual skill is relatively rare, because of which the ones that I know, typically when you hire them, their starting price will be around 2 to 3 million for a project, right? And they will give you the visualization. And sometimes you know that they are experts. They will do it actually in 3-4 months, right? Or 5 months or a year. But even for that, they will charge you something close to 7 figures sometimes. Right? So data visualization gurus, like the ones who are really good with it, the art of it and the thing, who can think through the aesthetics and tell a story, they are very, very sought after. They are the bridge between engineering and art. Right? And you know, this whole interplay between engineering and art has been, it's an interesting topic in its own right. If you, for example, ask, well, what is it that Apple did differently compared to all the laptop makers or computer makers, with the Dells and the Compacts of the world, the HPs of the world? If you think deeply about it, and so Apple, for example, is pretty, they don't give you a hardware which is the best. Even today, a Samsung smartphone is way, way more powerful than Apple, even the latest Apple iPhone. Right? It's a given. It will be. And so again, I mean, obviously I'm oversimplifying. Apple has been very clear from the beginning. They are into industrial design, right? They bring together the hardware technology and they bring art together, design and art and aesthetics, and they merge the two. And the whole operating system also has the same throughout their product cycle, whether they are building hardware products or they're building software products. Usability is front and center for them, and beauty and aesthetics is front and center. And so you can see the effect. What is it today? It's is it fair to say that it's one of the most, the highest, what is it called, a market cap?
Yeah. 1.3
trillion. It's $1 trillion company, right? But almost $2 trillion company.
No,
$3 trillion company, right? So think about They reached 3 trillion. So guys, think about it. 3 trillion is more than the wealth of many nations, isn't it? And what is true for big companies like Apple, etc. I happen to know, and if you just look around in 5 minutes, you can find out it's true. People who are deep visualization gurus, it's true for them too, right? There is a huge career out here in data visualization, but you have to become good at it, very good at it. And so it's a journey. And I hope that's some motivation to go back and read and review the old notebooks. Okay? So today I'll start by reviewing what did we do last time? We did bar plots and we did scatter plots. The main thing we learned is, and you take a systematic approach, somewhat like resonating with the grammar of graphics. You lay, it's like building a house. You lay the foundation, right? And then layer by layer, you put pieces together. And you slowly build a house. Whenever you see a visualization, think of it like a house, right? Or if you're used to Photoshop as a final graphics that will be sitting upon many layers that you have put in Photoshop. Right? So that's how it is. Build it slowly. And so we went from bar plot, which was a one-liner, to fairly. For example, we end with the landmark Nightingale's 2 roses visualization. And at each part of the journey, we just added one statement most of the time, 1 or 2 statements, right? Or simple things. So you gradually built it up. Then we did scatter plots, and we saw scatter plots using different libraries. Again, we started with one-liners. And I hope you would agree that by the time we ended, our scatter plots were looking very good. But to cap it off, I would like to end that scatter plot discussion itself with a landmark visualization. In the world of visualization, and this is a visualization that many of you may have seen, it is called the Health and Wealth of Nations. It is one of those visualizations that captures so much of the history of the world in an objective, non-biased perspective. The moment we talk about history, the moment we talk about how the wealth of nations or how nations have done well or not, you ask this question, was, for example, colonialism good? For example, India has been colonized and China has colonized, and Asia, much of Asia was colonized for almost 200 years. In this time, there are 2 perspectives. If you go and ask the Asians, they will say, oh, a bunch of really cruel barbarians came and took over our land. It was decimated, right? It was plundered. And well, that's one perspective. There's some truth to that. Now, there's another perspective. If you look at it from the Eurocentric perspective, there the perspective is, we were the people who took, well, depending upon, we took Christianity, the light of Christianity, we took the light of knowledge, to these people who had gotten really fallen behind. We took steam engines, we took train and railways, we took this and that, and modern systems, and we essentially created a scientific, brought them into the modern world, all of these countries. So these are entirely different perspectives. But if you ask this question, okay, so these are 2 perspectives. But if you look at some very basic, let's look at for example, the longevity. If you say that longevity is some very rough single measure of how well people in a country are doing, right? Because you can't live too long if you're starving, right? You can't live too long if the whole nation doesn't have a medical infrastructure of a reasonable kind, right? Basic medical infrastructure. On the other hand, what is the wealth of these nations? How well are they doing? Are people able to save money, earn enough, and so forth? So health and wealth, you can think of it as 2 axes by which you can see the evolution of nations over a period of a couple of 100 years. Right? So that was a visualization. That was the famous Gapminder wealth of health and wealth of nation visualization. And let us go to that particular visual. This has been a celebrated visualization that has been talked about many times. So, and it was created, well, there's a bit of history to that. We'll come to the history to that. It was created by a Swedish professor, Hans, something I remember his name, Rosling, I believe, Hans Rosling. So his son, if I remember right, is in Google. So anyway, he created this visualization. What it shows you is we will start with the year, which is, let's go to the year 1799, right? Let's go back more than 200 years and see how the countries have been doing around the world with respect to life expectancy and income. So on the y-axis is life expectancy. It's a linear scale from 0 to, let's say, 90 or 100 years. Then income. Now, you notice that income is strange. It is a little bit 50, 100, 2000, 4000. It is on an exponential scale. Do you see this? The y-axis is not linear. It keeps doubling every unit interval. It keeps doubling to the power. So we will see the wealth of nations, and you see it carefully. I will play this visualization and just pay attention to what happens. By the way, just to give you a clue, let's go and look at some of the major nations. This is China. This big circle that you see is China. And this circle that you see is India. 1799, right? What is the life expectancy in India? 25 years, right? 25 years is literally shows that, and the wealth is very low. And what it shows is that per person, what is the GDP, or GDP of the nation per capita, is pretty low. The country was in shambles. That was the time. I mean, obviously the Indian history, you guys will remember, all of those, the East India Company had just come and they started toppling over all the kings and taking over the country at that time. Right? So this is about that time. China was, they're slightly better, not by far. But what about countries that were doing well? Look at this. This is Germany, this France, Russia, Italy, and this United Kingdom. So United Kingdom had a 50% higher practically longevity and wealth. It was doing pretty good. And there were other nations that were doing good. Germany was a power, mighty power. France was a power. These countries were doing pretty well. And then there were countries which were doing very much like India and China, pretty bad. So if you look at the history of the nations, these were all, the yellow countries were the countries that had already started benefiting from the scientific revolution, right? And from the Renaissance and all of that. But the other nations weren't. So let's play this visualization. And I ask you to pay attention to what happens around 1945 to 1950. Right? That's the period in which more or less colonialism in Asia ended, and see what happens at that time. I'll try to stop it at that time. So you realize that for the longest time, not much is happening. You notice that India and China are actually getting a little poorer, right? And their life expectancy is falling. For example, if I stop here, what happens under 1876? Life expectancy in India has dipped to 19 years, right? Isn't it unbelievable? This is how low it went. And then you gradually see that this is about the post First World War. Let's go back to the time of the just before the First World War. You realize that it's still pretty bad, but what happens to these nations? They have been rapidly progressing.
They keep growing.
They keep growing rapidly. So you could literally see the gap between European progress and the progress of the rest of the world, isn't it? They were benefiting fully from the Industrial Revolution, right? And the effects were obvious. If anybody has to question, for example, people actually even today debate, did Industrial Revolution lead to any progress or any benefit? Well, it will forever remain debatable depending upon which lens you look at it from. But if you look at it from the lens of expectancy and income, this has a story to tell. Just by going from here, let's say here to here, what do you notice? Countries which had Industrial Revolution had a rapid increase of health and wealth.
What one green?
This guy,
United States.
this is the United
United
States, right?
America.
So Americas, right? Greens are the Americas. So it is beginning to do it. So here's the legend at the top here. The greens are there, blues are Africa, pinks are Asia, yellows are Europe. So you could literally see that countries benefiting from that. Now let's see what happens here. By now, like all of these countries are doing pretty poorly, Asia and Africa. And now see, gradually, it stays more or less the same. See, 39. Things are improving a little bit. China, India is beginning to improve. Then comes
World War II.
yeah, World War II. And around World War II, what you notice is, surprisingly, that some countries, they took a dip. Russia took quite a beating in the 1930s, between the two world wars. Remember, that was the time in which the rule of Stalin and whatnot, other dictators, many other factors were involved. That was happening. It was taking a dip, or I don't know the data, how accurate the data is. But yes, these East European countries were doing pretty poorly. Then comes, if you just move forward a little bit and look at the end of the Second World War. By end of the Second World War, do you realize that the healthiest and the wealthiest nation, the nation with pretty leading, except for minor other countries like Sweden and Norway, Scandinavian countries always tend to have, those Vikings, I guess, have a pretty good life expectancy. What you notice is United States has already become amongst the wealthiest nations, except for Switzerland. Right? Switzerland, of course, also tremendously benefited during the war, because guess where all the dictators hide their money?
Swiss banks.
Yes, war. I mean, it's always been a statement, for better or for, I don't know how fair it is, that wars benefit Switzerland. So it is very convenient for them to say we are neutral. So,
So there's something interesting you can do. Say, you search a country. That's for the thing of it. Search Afghanistan, and pretty nicely done the visualization.
right, you can limit it to
Yeah,
just
then
Afghanistan.
after
Yes, you could do that. This is Afghanistan, and when you run the visualization, you can literally see this
it actually
little.
goes
Yes,
backwards. See?
yes, you notice that. It is doing. This is where the Afghan war. You know,
Correct.
the Russians invading Afghanistan and so forth. And then, at one point in 1993, it again goes back huge in the wealth. It really goes back in the wealth of nations. But yes, you could see the life of these people.
Such a great visualization, right?
It is. So guys, what I wanted to say is, when this visualization came, it was a game, like people were fascinated. I remember playing with it for just endlessly, right? Once it comes about, because there is so much of storytelling, so much of history captured in one visualization. And at the end of it, what is it, guys? It's a scatter plot. Do you see that? Right? So never underestimate, never say, oh, scatter plot, it's just one line code. It's not. You have to think how to tell a story using the simplest means. Right? And so you look at this, what has been happening? It has a very peculiar, now, because since you picked up Afghanistan, Sachin, I'll just tell you a bit of a fact. Afghanistan is a strange land. Every single power in the world that has deemed itself to be a superpower, every single power in history, starting with Alexander, it has been their fate to go and conquer Afghanistan at some point or the other. It's a very interesting part of history. It's a land that always is invaded because of its location or for whatever reason. But there's another side. So for example, if you go to Afghanistan, you will actually still find the ancient, like Greeks who came with Alexander and attacked and then never went back, settled down there. You'll actually find people of Greek descent with blue eyes, right? They are still living there. And so you can see waves and waves of invaders come to this land, think that they will invade it and say, but here is the second part of that. It has never successfully ever been conquered. And the reason for that is the mountain regions of Afghanistan, they're tribals. I mean, they just, you go there, a lot of people by modern standards, they would be considered backward and they're brutal to women and whatnot. But the other fact of that is they're almost impossible to conquer, right? They are very fierce warriors. And so far, the history of the world has nobody has conquered Afghanistan. So anyway, so like that, we can talk about the history of anything. Let's look at the history of India in the same strain. India. I take this, and let me also put the history of something else. Whenever you have India, we always have this other thing, the China, that the comparison is often done. So let's look at 1799. These countries were not at war in those times. If you go back and look at it, there was a huge cultural propagation for 2,000 years. The southern parts of and the eastern parts of China has been de facto Buddhist lands. Right? And great scholars from China and from these lands would come to India. You would remember Hume Sang, one of the greatest travelers coming to India and learning from. So there was a large degree of cultural exchange and mutual respect between these two great nations of the East. Look at their fate and how their fate goes with time. Well, India is a little bit, life expectancy is a bit lower because it's the tropics, there are more germs, etc. This is more temperate climate, but let's see, let's progress it from there. What do you notice? As colonialism comes, do you see the life expectancy go up or go down in these nations?
More or less staying same right now.
Going down.
Now going down.
Going down, right? Going down and going down and
Further.
bouncing further, and you realize that it keeps reaching a below of 19.4, right, in these places. And now see what happens when these nations finally, so like these nations were asked to contribute to the Allied forces during the First and the Second World War, which they did. And so they became more understood and science began to come. And now see, I will just roll it back to 1945, 44. And see from here, if you see a rapid change from this point onwards, these countries become free. And what happens? Do you see that the trajectories? What's happening to these trajectories now?
Life expectancy is increasing.
And the wealth of nation is rapidly increasing. So does it answer the question, was colonialism a force for the good or not? As far as these countries are concerned.
It does.
It does, right? It's a strong argument that getting rid of colonialism was a good thing, right? These nations.
It's extractive, taking the resources.
Exactly.
So that's exactly what colonialism was hugely
That's right.
about.
That's right. I mean, even today, I get people who keep assuring me that if only these countries had not been conquered, they would be living in abject poverty and dying like flies. But so things like that. So so guys, here's the thing. What is it? It is objective reality, but it tells a story, compelling story. Would you agree? And that is the value of good data visualization. Obviously, this data visualization became a landmark visualization in the world of visualizations. We did scatter plots. Now, I will let Kyle take you through and make you do, I mean, depends upon whether you want to do it or not, there'll be a scarce time, but at least walk you through the code of reproducing it. Now, something so powerful, do you think we can reproduce? From what you have learned, do you think you guys can reproduce?
Yes.
Yes, you have learned everything needed last week to be able to deconstruct this and reproduce it. So let's look at something. Can we make the x-axis on a logarithmic scale? Yes, Matplotlib, everything gives you the ability to make the scales like that. Could we draw the grid lines? Of course, a no-brainer. Could we put this 2020, the year that is there? Do you see that it exists as a as this? What do you think we can use to write this? It is just text. Matplotlib gives you a text construct. Each of these libraries give you a text construct, or you can think of it as some sort of just an annotation or something, text or annotation in the background. You can put, do we know how to change the size of the bubbles?
Yeah.
Yes.
Of course we do. Do we know how to color the bubbles? We do.
Yes.
So if you take any one fixed year, you know all the elements here. Would you agree?
Yep.
You
Yes.
can draw it, and then all you have to do is do it over a time series, over the years. Now, in the public space, this entire full data set is not easily available. If one of you can get hold of it, certainly please contribute it to us. We have data for a more limited number of years in the public domain. So
what do you mean data is not available?
this data, right, it's in a very sort of complicated form. So to put it in a simple form, that country, year, life expectancy, and wealth in GDP, just 4-column data, right? The way we would want it. I wasn't able to find it. Maybe you can.
So
If you
I
can,
put this
Sachin.
in the website, answering the.
Yeah,
other-
try that.
So you're saying that all data should be available to people, should be able to. go and
Yes.
get the thing. So I was
Yeah,
thinking
yeah.
it was available.
No, poke around it. I didn't succeed in pulling it through. But if you can, Sachin, you would really, I would love to, in the next iteration of this workshop, when we implement it, I would love to implement it on the full range of 220 years. So please help us out with that. All right, guys. So now I'll hand over to Kyle, who has done wonderful work on this and created this. And by the way, this gentleman that you see here, Hans Rosling, he is a professor in Sweden, and he created this visualization. Right? It has been obviously presented everywhere now. And what I'm saying is, guys, you already have the tools now to create powerful visualizations. Kyle, please take over.
He passed away.
Oh, Hans,
Yeah,
Ross-
2007.
oh, he passed away. Sorry to hear that.
So he published a book, him, his son, and daughter-in-law.
Really?
Yeah, so the foundation basically says that people should, so they quote quite a lot with schools and all,
Yeah.
saying that you should look at data in a completely unbiased way and get to the
Right.
bottom of it. That's
Exactly. No, definitely. I would love to buy the book. In fact, it's the first thing I'll do. I'll go buy the book.
Could you
Okay, Kyle.
share the information on the book that was just mentioned?
Yes, Sachin, please put it on our slide.
Thank you.
Okay, so like Asif said, we will be recreating the Gapminder Wealth of Nations visualization with what we've learned so far. So let us start with Matplotlib. We'll also learn to create the visualization using Altair and Plotly. So let's first start with the imports. So here we run visualization imports notebook, which you already have. So you just run this line of code. Then we also import Altair, which we use it later on. You don't need it here anyway. Then here is the plot style dictionary, which instead of updating each individual font separately, we create a dictionary with all the font styles that we want. So including axis, X-ticks, figure, title size, everything put together.
Yeah.
And then
One second, Kyle. Guys, so this is it. Remember we have been using the resource control, RC, and then giving it in a map like key value pairs, which we have done everywhere. But I think this is a superior way. The way Kyle has done this is a different way of configuring all of it at one go. It is as you can see, it is like a JSON, and in one go you can set all of it and then do plot style, use ggplot. So I would encourage you to use this way now.
But Kyle, this is like a hard coding thing, right?
Yeah,
Because these values,
typically
yeah.
what happens, right, is that, see, if you notice, we have a style. Everybody has some base style. You put your base style somewhere so that all your visualizations look alike. Imagine that you're writing a book. Would you like each of your visualizations to be in a different style or look different? You would like them to be standardized, isn't it? Just as when you write text, you standardize the spacing between the lines and the width of the lines. Think of it like that. whenever you do visualizations, take a standard and then change the standard as, because you can always do RC parameter. Those RC way on a case-by-case basis, you can still do that, but you can start with a baseline.
Yes, instead of using numbers, there is another option where you can set like small, large, medium, and then in terms of the size of your plot, you can set those code words instead. So that is also possible. But here I've, like you said, hard coded with numbers. So that you can do it as well. Okay, so now we are going to load this data set. So in this data set, like Asif said, we are using a limited number of observations. So we start from the year 1952 to 2007, and we take 5 years gap instead of individual years. So it's 1952, 1957, and so on. So let's load this data set, and I'll just post this source on Slack.
All right.
Yeah. So you can run this, load this data, and create a pandas data frame out of it, like so. Can I move forward?
Oh, yes, this is standard, guys. I hope this is all very familiar to all of you by now. We should move rapidly forward.
Okay. So then here I'm describing this data frame. So we see that we have two categorical variables. One is the country, the other is the continent. And then the rest are all quantitative variables. So here we see that year starts from 1952 and the max is 2007. So now
Guys,
let's
are you
plot.
typing it in? Are you guys doing it on your machines? No. Do that.
No.
At least the one basic version is good. Could you please do it from the beginning? Maybe I'll take them from the top. Just
Okay.
have them do at least one version.
Okay.
It's a little difficult to watch and do it at the same time.
No, you can paste the code. Harini, if you can keep pasting the code, Harini can do that.
Okay.
Or take one of you, please.
I think Kate would be better because I am having internet issues to log in.
Okay.
So I'm doing
Okay.
it from my phone.
Sure. Okay. I'll start pasting that into the Slack channel.
So guys, let's
Thank
take a
you.
minute to catch up. It is worth doing this exercise. Let's do this. And only paste the hard parts of the code. Don't paste everything. Like when you see it's more than 4 or 5 lines, then we paste it. Others we should type it.
Okay. The long chunks. Okay. I'll do that.
Okay.
So let's
So now, before we move forward, it's a good idea to, so first of all, continent is a categorical variable, and we would like to label encode it into numerical codes, say from Africa 0, Asia 1, and so on, so that later on we could use this information in our scatter plots. So how we do that is we first of all convert the continent data into a categorical type. Then we do data continent.cat.codes, which automatically converts each unique category into numbers for us. So
Is
then-
that for 1 second, Kyle, like, is this code available online? Is the notebook available online for us? Which one is that?
Which one are you saying?
The notebook. This one we're showing
Oh,
right
no,
now.
we don't want to give you the notebook till you
Oh, okay.
finish the exercise. See,
Okay.
just like last week, we make notebooks available after you have done the exercise. The point
Okay.
is, if we give it to you, there is no reason for you to type and learn. You just read it and say, okay, now I know.
Yeah, but last time also we had issues with long, what is that, lines of code, right? So we had to copy it somewhere. So is somebody going to
it's on
copy it for
Slack.
us?
Kate is putting it on Slack.
Okay, okay, thank you.
Kate, are we there? You're putting it there, right?
Yes. Yes, I'm putting in the,
So for now, the first scatter plot that we make is
so
very
let me make
simple.
sure it's in Viz. I think I've got it in general.
Yes, it's not showing up in the channel.
Yeah, yeah, sorry, wrong channel. Let me put it in the correct channel.
Yeah. So Kyle, wait a minute.
Yeah.
And I'm also getting echoes, guys. Can you please mute yourself if you are not speaking? Let's wait for those codes to show up.
So after we do that, we also just filter the data frame by year. So before we plot it for each individual year we have, we do it for one single year. So then we can improve upon it later on.
Kyle,
The
please
first
wait.
data frame.
Kate, for some reason, I'm not seeing any code in the
I'm
Slack
trying to
channel.
get to the, I have so many other Slack channels and my Viz
Oh, sorry.
100
Oh,
is
yeah.
like
Should I start doing it?
disappeared.
Yeah.
Maybe.
Yeah, let me click on that. There we go. Okay,
Let's wait a minute, guys, till you get over.
okay, let me just start. Yeah, I'm in the right channel now.
Yeah.
Can we put the date in a code block?
Yes. So
that
work,
means
work
Slack,
with
you have a code block.
that is right. So Kate, please put it in a code block. You know, the Slack gives you this little icon for code block. And if we could use the code block to put
Oh,
the code.
yes.
All right, guys, so let's start with this, the code that we have. Can we go from the beginning so people don't feel lost? Kyle, sorry, it's getting very
Yeah,
confusing.
yeah.
So we are going to start from the very beginning. Guys, huh? So
Okay.
this style, the first part is there, plot style, etc. Have we given this code? Yes, so we have that code.
The other thing, Asil,
Yes,
what it can also do is just edit the same block and add the code
just the
to
extra.
that thing, so that
Sure.
we just have one full thing rather than a bunch of Slack.
Okay.
Yeah, let's see how much we can do. Okay, so let's go back.
Yeah, if you can just
Yeah.
edit it and just post the remaining portion in it.
I think I could just make it cell by cell. I'm putting it in. It won't take that long. And the cells are in order.
And of course, guys, the reason I'm not releasing the notebook is it's good that you do it.
Yeah.
If you don't do it, you won't learn. You have to see the process of slow construction. You're building a house, little piece by piece. You're not doing anything very hard at any one step. You're just adding little pieces. All right, guys, should we start now? This is your, yeah. So the source part, let's stop here. Are we all done with this part? Have we reached this far? Let's stop here, the second step.
Yep. You can
Not
raise
yet,
your
not
hand
yet.
on Slack if you're
I
done.
have not reached here yet.
So
Okay.
whosoever has not reached, speak up and we'll wait. Okay, so let's wait for everyone to reach a baseline and then we should, guys, together move fast.
If you are stuck, you can post it on Slack and I can help you.
Okay, thanks, Hari. Kashish, I think it was who said you're not yet. When you get there, say that you are there. Anyone else who is not yet there?
Do we have to run the visualization imports in every notebook, or do you just do it once?
Every
Like I was
notebook.
Every cell.
every notebook.
Run every
Okay.
cell. Yeah. That's the Jupyter spirit, you know. Slowly you build it up cell by cell. So could we say that cell number 1 is done? That's taken from just the Slack message. And cell number 2. Cell number 2 is quite literally just loading the data as a pandas data frame, which you all are used to by now.
Yeah, code's been pasted up to the add legend. Should I wait until everyone's caught up?
I'm sorry, Kate, please say that again.
I have pasted the code to the point of 1.3.1, the add legend.
Okay.
No. Yeah. So yeah, let's wait a little for
Okay.
people to just. I want a confirmation that we have all reached at least cell number 3. Anyone who has not reached cell number 3? All right, Sachin, we'll wait. Let me know when you have. Hold on, guys.
Oops. Some people are missing the visualization imports notebook. I had
Just upload it.
I put it in the I pasted that to Slack before.
Okay, let's add it to Slack again. One
Okay.
of you, please.
All right, I'll do that. I will
Okay.
reply to him.
So I'm not seeing any activity on the Slack, like whatever you're posting, I'm not able to see the code.
Easy 100, the Slack channel.
Yeah, we can see it.
What is the
Prashant,
Slack
look
channel?
at Easy 100.
So it's
Are you
this
in that
channel.
Slack channel, Prashant? All right, guys. Anybody else who is struggling? Prashant, where are you? Are you there now? Prashant Gupta, how far are you? You're on mute. Okay, we are not hearing from Prashant Gupta, so I'll assume he's making progress. Guys, we need to quickly reach cell number 3. Stay on cell number 3, please. Yeah. Have we reached this place? We are able to just see the description of the data. If you have not, let me know. If nobody speaks up, I'll assume we are. I'll take it as a baseline. Now we'll move fast. So,
Yeah, I just joined the channel. Yeah.
I got an error. It's saying that PLT is not defined. The very
because,
first one, the import alter as alt, and I don't know if I forgot to import something else.
you have to run this visualization imports.
Yes.
So take that file. Yeah.
It's not running for some reason. It was giving me error, so I copy pasted everything that was in that particular
Yeah, that is it. Then just
notebook
copy paste.
and ran it. But still, I'm getting an error. That runs, but afterwards, it's giving me error that the PLT is not defined. Maybe I need to say
Could you please
matplotlib,
share your
import
screen?
matplotlib.
You can
could
just do
please share
this
your
instead.
screen?
Yeah, I didn't write the import matplotlib. Let me just import.
You can just
copy that.
Yeah.
Yeah, import matplotlib.
And you'd also have to do import if you don't have the notebook yet. You can just do this.
Yeah, import. PV. All right, perfect. Let me run this.
Yeah.
Okay. I'll wait. Yeah, it ran. Mhm.
Okay, good.
Thank you. Yeah, I'm there.
Okay.
And guys, visualization imports, you'll see in your Slack channel. Just put it in your data. So are we all at number 3, cell number 3? Kyle, please stay at cell number 3.
Okay.
I want
yes.
to baseline everyone before we make progress. Anyone who is not yet here, Prashant, Avanti, anybody?
I got it.
We all got to this. All right, guys. So if we are here, I think people have started taking a bio break. It's let me ring the bell. It's taking us quite some time to baseline.
Okay.
All right, guys. So let's do cell number 4, which is a little bit of data manipulation to create some new columns. And Kyle explained what those are. 3 new columns. One of them is continent codes, and year. I mean, a new data frame by a particular year. If you want to limit it to a particular year, you could do it like this, right? All right, guys. Are we here at this point? Cell number 4, have we copied into the Slack for people to play with?
So Asif, go back to the previous one, just one level higher.
Yes, cell number 3.
Describe parameters. Is that really that line need?
Okay, 1.4.
That is, I mean, it's only just for you to get a sense of the data. This is the statistics of the data. That is it.
Yes, go down.
All right, guys. So let's move forward. This one, have we all reached cell number 4 and run it?
Yes.
Yeah, this is all exploratory data analysis, guys. We haven't gotten to visualization yet. Now we will get to it. So now let's pay attention to this cell. What we are doing is what is the x-axis? It was the GDP per capita, and the y-axis was the life expectancy, if you remember, isn't it? And so Kyle has just plotted it out and given some labels. This code, I want you all to type it in. Let's not give it to you, because by now this should have become very familiar to you. We are looking at a particular year's data, which is 1982. Let's take a couple of minutes to finish it off.
So I have a question. Where does it say that we have picked a particular year? Because
Oh, just to one line. She decided
Oh,
to just
up
pick a
there.
random
Oh,
year,
okay.
1982 for reference. And
okay,
said, all right, let's create another data frame limited to only that. And we'll visualize only one year. So at this moment, we won't do the animation. One frame of a video. Right? If you think of video and frames, one frame of a video.
So once you run this code, your plot should look something like this.
It's a very basic plot. So guys, make sure we won't make progress. Just keep it at the code, please. A little bit. Yeah, that's it. That's wonderful. Please type it in, and you have a couple of more minutes, a minute to do. It is important, guys, that the basic of plotting by now, you're very comfortable with. Guys, come by and let's start doing it as if you were in the coffee room.
Shall we move forward?
Is everybody done? Can I assume? Raise your hand if you are not done. Oh, so if you're getting problem with LaTeX, Kashish, just disable it. Set LaTeX false somewhere up there. All right, at the top, just you can set LaTeX as false and remove all these LaTeX commands, text BF, etc., etc. You can just remove it. You know where you have the use LaTeX, just mark it as false. All right, guys.
Right up here,
Right up.
you can set this to false and run the cell again.
Yeah.
Okay.
All right, guys,
So
at this
now-
moment, can I assume that this is it? We have all reached this level. If you haven't, now is the time to speak up because it's a foundation we'll build on. Gopal, you're still working on it?
Yes, it's working in the back end. I don't know what it's doing. Maybe LaTeX is taking time. I don't know.
Just disable LaTeX. Just go to use text and set it to false.
Oh, no. Yes, I got it. It took
Okay,
some time.
wonderful.
It came back.
So
Thank you.
now let's look at this and see. First thing we notice in the previous graph, if you go to the previous graph, Karen, if you get this, look at this graph. What have we not done? We have not exploited color and we have not exploited size. Remember, in 2 dimensions, we can actually show 4 dimensions of data. X and Y are taken, income, life expectancy, but we can still exploit the size and the color of the points or the bubbles to show 2 more things. And you see that. So the only code change we make now, are the two color S and C. Do you notice that S and C? And then we have added some color map. Color map just adds to the beauty. Remember, I told that there are many color maps available. Kyle has selected set one, which is a well-known color map. So Kyle, could you please highlight only those 3 lines with your mouse? Yes. So guys, let's add, an edge color, some things for aesthetics. So we are adding only this much. Could you please add these 3 lines, all of you? It is not something we want to share simply because we want you to type it in.
We linearly scale the population because population is, if we make the marker size as the population, they become very large. So we shrink it down a bit and then.
Yes.
How do you choose that value, like 300?
I chose it randomly. First I plotted it, it was very large. So it was a trial and error method.
So this is the art part of it. You have to play and figure it out.
So this is how your plot is supposed to look.
So guys, at this moment, I will assume that all of you are looking at this plot on your laptops. You are?
Yes.
Abhishek, very good. But Sanjeev, you got here? Where are you? Oh, you're getting too many errors. Maybe you can work with Harini. She can help you catch up. Okay, guys,
Yeah,
those of you
sure,
who are
sir.
others, anyone else in the Zoom who has not reached this place, raise your hand. Prashant, are you there? Prashant Patil? Prashant. Anybody who's not there?
Yes, I reached already.
Okay, wonderful. So I'll assume that all of you have joined. So let's make progress, guys. Huh? Do you notice that all we did is we exploited the fact that we can use color and size to do it. Now let's move forward.
Oh, okay.
So we notice that this plot is not very good as a linear because the income has an exponential sort of a distribution. Poor countries make orders of magnitude less than wealthy countries. So the X scale we can change to a logarithmic scale. And how do we do that? We just add 1 line of code. This is one of the beauty of Matplotlib. And all these libraries, they will give you the scaling, log scaling of axes automatically. So let's add this 1 line to your code in which you scale the axis. And when you do that, you should see it now like this. It looks a little bit more linear and more along the lines of what the Gapminder visualization is. And do you see that we are getting closer to it now? 1 frame, just 1 frame, and we're getting a bit closer to it. Are we? If you are not here, let me know.
When you added that log line,
Just show that plot.xscale log.
just do that. You only have to put all the entire thing below.
Oh, yes, yes. All you do, see, guys, all you do is take your previous cell, copy it over, and then add this one. Or in the same cell, go and add this one and see how it reacts. Don't have to create more cells. You can just, if you want, put it there. But if you create new cells, then you will see the evolution of your graph throughout the Jupyter Notebook. Are we there now? Albert, are we there? Yeah. Okay, let's go forward now. Now we add legends. Do we remember that legends? All these colors and all of these, we need to say what those colors are. So how do we do?
Yes, with
legends?
Matplotlib, there are 2 ways to create legends. As in, we either first group our data based on so we want the colors, we want to show the legend of the colors. So either we first group the data based on different continents and then plot them separately and mark the labels each time. So that is one method. But here what we are doing is we make use of legend elements. So plt.scatter returns a path collection object, and this path collection object has something called legend elements, which returns two things, handles and labels. So we manipulate them to get our legend, and that is what is plotted over there. So the handles refer to each of the continents. So there'll be the markers, and labels are the text that comes with the markers. So we keep the handles the same, but our labels are usually, since we used continent codes, they would be 0, 1, 2, 3, 4. But here we want the names of the continents, and therefore we use this data continent.cat.categories, which will return all the unique categories of this column.
This bit
Then-
of code, guys, is very useful. You don't easily find it, but this question keeps coming up over and over again. You know what? I color coded it by a number, some code, but each code has a text associated with it. What I want to show on legend is the text. How would I do it? So this bit of code does that for you. It helps you just map a code to a legend, to a text in the legend. So guys, take a minute to type this in. It's a little, 2, 3, 4 lines of code. Please type it in. We'll make progress after that. And make sure that legends show up. Let's take another 30 seconds and we'll move on. Are we all there?
Yes.
You're there, Abhishek? And Sanjeev, you are taking help from Harini? Okay. Anybody online who is not yet there or wants us to wait? All right, let's make progress then. So now it looks like this. You know, you see an improvement, legends have come. So you see that little steps by little steps, we are making progress. Now let's go ahead.
Now we're going to take a huge step actually. So here, now we're going to animate it. So now we've just created one frame. Next, we're going to create it for each year we have in our data set. So before that, it's useful to know how we do it. We use Func animation to do it. And Func animation, if you want to use Func animation, you have to follow these 3 tasks. And if you do these 3 tasks, it's simple. So first you need to have a setup, the base plot and a setup. So this is, so the base plot is what you want to modify every time you, and in each frame, this is what you want to modify. And the setup is what remains constant throughout your animation. For example, your X labels, Y labels, titles, all that is static in your animation, you put it under setup. Then you create an update function. So this update function updates the base plot. So this is what gets updated every time for each frame. And in the last is you create animation using Func animation. So you put all of them together and pass it on to Func animation, and it creates your animation for you. So
one second, Kyle, just stop at element 9, cell 9, and let's have people
Yes.
type that. So guys, please take a moment to type that in. After that, Kyle, could you please highlight the sections, which is just a copy from before?
okay.
Just with your
The-
mouse, highlight from all the way. Even that fig style, use ggplot, etc. is additions, right? Okay. So
Yes.
So first, we are going to give it some styles in the figure size and style, etc., etc. You may want to do this, guys. It is time to do this. Apply the styles and then copy over your previous cell right after that.
And there's an import error for animation.
I'm sorry. Say that
I made
again.
an error on the animation, importing animation, Func animation, which is
Oh,
not there.
Okay.
Is anyone else getting that? Maybe we need to install a library. Did you need to install a library? Func animation.
I did.
I don't get an error.
You don't get an error?
I don't get.
Oh, so in your case, right, just do, if you're getting an error, just do go to your shell, or in one cell, just do exclamation pip install matplotlib -- upgrade. Just upgrade your matplotlib. See what happens. Gopal, this is you.
Yes. Pip
Yeah. So
install.
what I would do is reinstall matplotlib with the upgrade option, -- upgrade. So guys, are we all here? Have we done this import other than Gopal? Have we matplotlib, func animation, and display? And have we done this little bit of setting the figure size, the style, and so forth? So I'll assume it is yes, unless you guys say no. Are we all there? Everybody in the class, are we there?
Yeah, just the bubble, the scatter plot and the legend, right? I have not done the
Yes.
setup. That does not.
Okay, yes.
That is it. Copy paste. And now we do some extra stuff just to make sure that these things don't change. Kyle will explain. Yes.
Yes.
Mhm.
So we know that the income ranges from 100 to 10 power 2 to 10 to the power 5. So since I looked it up manually, I'm putting it up here. Then similarly, the age life expectancy ranges from 25 to 90. So we put it up so that for each frame, we don't want the limits to keep changing. So we'll have a jittering sort of an effect if we don't set the limits prior. So we do that now. Then we do the same thing, similar to what we did earlier. This is the same code from before, and so is this. So we just add these two lines here. So this is the setup, and this doesn't change.
The subtitle, that one is new, right? Yeah.
Yes.
We didn't have that.
Yes, you can. Yes, you have to write subtitle. So subtitle is basically a super title. Since in our animation we will keep changing the year, so the title will keep changing, but subtitle remains the same. So keep it that way. So after that, yeah, super title. So next is the update function. This is what we want to change for every frame. So for every frame, we would like to update the year by 5. So we start with 1952, and every year we want to update it by 5, so that then we select from data that particular all observations with year equals to the year that we just found. So then we do the same thing. So next what we do is we set offsets. So set offsets changes the position of the points. So if the position was for 1952, it was something, now it will get updated when we use this set offsets. And similarly, we set sizes. So we change the size of the points as well. Then we change the title to the year that to the current year, and we do a plot type layout here at the end. This is our update function.
This part, could you please paste it?
Yeah.
Because this is new code. It will take you folks to get used to this code. All it is doing is it's saying, okay, each bubble, where should it belong and how big should it be? Those are the two main changes. If you look at it for a given year, what is the bubble? Where does each bubble need to be, and what size they should be?
If there's a section of that cell or the whole cell you want me to copy in the Slack at some point.
The update function part.
The update function.
Yeah, and even this
animate part. The animate part also, please paste it. So from update function all the way to the end, let's paste it, and then we will talk through it.
Okay.
Go ahead.
So the last part the third part is creating the animation. So here we use the func animation method, and we pass in the figure that we are creating. So here we set figure equals PLT, and we set this figure, and this particular bubble plot is plotted in this figure. So we pass in the figure, then we pass in our update function, and we pass in the number of frames. So this basically means how many times we want to call the update function. So that is 12 times, and the interval. So in between each frame, how many seconds do we want? So here we set it 2000 milliseconds. So
Essentially 1 second.
yes, 1 second. And this is just standard code. You convert it into a video, you convert this animation to video, then you display the HTML. And once you do this part, you should see this animation show up.
It gives me an error that requested movie writer not available.
Oh,
Okay.
I got the same
animate
error.
into HTML5. Are you, see, update your matplotlib. All of you who are having errors, most likely you have an older version of matplotlib. So if you just do pip install matplotlib with a -- upgrade option, upgrade your matplotlib, because these are actually recent additions to matplotlib.
What did you say? Hi.
Let me, Kyle, could
pasting
you
it in Slack.
create a new
Yes.
cell? Just create a new cell, Kyle, somewhere in a new notebook or whatever. Yeah.
Yeah,
just
just
here.
above it.
Exclamation,
Yeah.
exclamation. Pip install matplotlib upgrade. Yeah. So please try, and maybe you can paste it to Slack. Let's do this for all of you. Actually, this is something we're doing for all of us, guys. Let's do that. Because matplotlib is a fast evolving library, and it's worth doing anyway for all of us. So no, wait a minute. Let's let people
Yes.
reach that place. So folks, I want you to all be able to, now that this whole code has been pasted, are we all able to get that moving visualization? Anyone who is not able to?
I'm getting the name fig is not defined.
Okay,
waiting
you have
for
to
it.
do that.
You
Oh,
probably
here at the
missed
top.
it.
Okay, okay. Not figure. This code put in there, I'll type it in.
Type it in, please.
Okay.
Because these things, you have to develop muscle memory for. It should become familiar to you now. So while we are doing that, guys, do you realize that we are already coming rather close to the visualization, isn't it? So now, are you all able to reach here, this visualization?
It's still giving me requested movie writer FFmpeg not available.
Oh, yes. I'm so sorry. You'll have to install FFmpeg for this. I
Okay,
think.
why don't you give that
I-
pip install command right here, Kyle, so that
I-
everybody can do that? No, in the notebook itself, please, in a notebook
Yeah,
cell.
it should be
itself,
short
put
to
that
type in, right?
I
So,
don't remember how I did it.
so Kyle, can you just do that RC params update? What is that you put in there? DF dot something. Can you just 1 second?
Yeah.
Params, update. Oh, update the plot style. Okay, okay. Thank you. FFmpeg not available.
Yes.
Yeah,
Okay.
just install pip install that. Yeah, FFmpeg. On your machine, just go and
FFmpeg.
install it. It's a MPEG. It will create an MPEG. So whichever is your operating system, please install it. If you have Ubuntu, you can do sudo apt install this thing. If you have Windows, the instructions, and likewise for Mac.
So I did that pip install ffmpeg Python, the one that, but it says the requirement already satisfied. And when
No,
I
you
run
may
that,
have the library. You have to go to the shell operating system level. You have to install FFmpeg. The reason is that that is a library not in Python. Python uses that library.
Not
I
available.
don't know how to do that.
Okay. For each, so Mac, Sachin, where is Sachin? Hey, Sachin, could you please guide all the people using Mac on how to install FFmpeg? Yeah. So Avanti here and anybody else using Mac was struggling. So I apologize, guys. I'm not a Mac person. I'm a Linux person. So let's take help from somebody who's good with Mac.
I can post me the full file, the full what do you call it? Python library, then I can the notebook, then I can run it and make sure it works.
Okay. So all right, you can do that. One of you, maybe Kate, could you please give only to Sachin the whole library, the whole Jupyter notebook?
Okay, I can do that. I can also, yeah, let's see, I just looked up some information on installing FFmpeg on map. I'll just, maybe this will be helpful. I'll also copy this.
So Ashish, is it FFmpeg hyphen Python
Yeah,
or
please paste it.
FFmpeg?
Yeah. So Avanti, Albert here says that you use something called Brew, which is a functionality to or a utility to install things on Macs. So Brew install FFmpeg, and he's putting the command onto the Slack.
I'm sorry, I could not hear you properly.
Yeah, there is a library, there is a utility in Mac called Brew, B-R-E-W. And it will automatically get integrated. You don't have to do that.
I did do pip install.
No, pip install is not enough. At the operating system level, you have to install FFmpeg, and there are instructions for each. Google up the instructions, you'll get instructions. Like for Mac, for Linux, I can tell you, all you have to do is apt install FFmpeg. For Mac, Albert is saying it is Brew install FFmpeg.
You need to have pre-installed the Brew itself, package itself.
Oh, Brew itself. Okay.
Yeah,
How do you do that? Could you please post?
No, there are instructions. If you just Google it.
Okay. So if you don't have Brew itself, then first you need to start by installing Brew. So guys, I apologize. Mac is an area of ignorance for me, but take help from each other on Slack. See,
Okay, Sachin, you have the notebook. Help the Mac people.
Kevin, if you have a link on how to install Brew, could you please put it? So guys, this is taking us rather long to do this visualization, but it is worth it. I want us to get here. Don't go down yet. Stay with that.
Yeah.
Just stay with that. We need to all baseline to this, guys, even if it takes us till lunchtime to do it. This is a very important visualization in the field of visualizations, and it is important that you reach this milestone. In fact, those of you who look for jobs in data visualization are quite likely to find this particular assignment to be your job interview question. How many of you are struggling to speak up?
I'm on Windows and FFmpeg is it's like hard to make it work. I don't even find the right exe to install.
Oh goodness.
For Windows, there is two options, exe file. One, it says Windows built from gyan.deb. And there's Windows built by BTBN. I'll just post.
Yeah, I saw that, but inside those, you don't get the exe files. Both of them, they use source code and then the zip files. I don't see any exes in them. I need to figure out which one has it.
Is it Brew you're talking about?
No, this is for Windows. Anybody has success with Windows?
I did, but I did it so long ago that I don't remember. I have to look it up.
Right. Yeah, guys, I apologize. You know, you stay in this field, you forget all the setup instructions. You assume that these things are there. So it's a good exercise. We are going through these struggles. So we will all learn collectively what is. Oh, okay. Thank you. So please look for Praveen's instructions on Slack. And while we are waiting for the rest of people, guys, sorry, I have to bring up an administrative thing. We are still missing the tuition from quite a few people. Did you receive my email instructions on how to, if you received an email from me yesterday, it means that we believe we haven't received your tuition. If that belief is wrong, you can tell us. Otherwise, please follow the instructions and please pay off the tuition. All right. Albert, Abhishek, did you have success? You had success. Yeah, would you like to just give it to everyone? That entire directory is zipped up?
Yeah.
Zip up the entire directory and put it on the Slack for Windows.
Okay.
No, you can do send to. Just go down to send to.
Okay.
Send to and
Yeah.
compressed folder. Yeah, zip folder. So yeah, now if you could put the zip file.
So there is some instructions online that I found. I've posted for Windows.
Okay.
I got the 3 exes, but it looks like they are directly running executables. I don't know how to integrate into Python then.
All right. See, here's the thing. If you guys are struggling with the animation, let's do one thing. Let's keep the animation as a separate session for Monday.
Yeah, sure.
Where we'll all sit together and fix the animation issues. Would that be reasonable? Okay, let's do that. And for those of you who have this installed, let's move forward. So there is a problem with the animation. It's very jittery. If you go back and look at the animation, sure. You look at this animation, it jumps. It's not smooth. Can you guys see it jumping around for those of you who got it? Or if you look on the screen, zoom.
Right.
It's lacking aesthetics. It's sort of jumping around. So the question is, how do you make it have a more aesthetically pleased, smooth transition? How do you make it flow?
Refresh rate is too slow.
Reduce the number of years instead of 5 years to.
Yeah. So she will talk. What you do is, and she'll explain that. Go ahead, Karen.
So in between each frame, we add, so we have 12 frames, but that is too less for us. We want to add more frames so that we don't have that jittery effect. So in between each of the 12 frames, we add another 15 frames. So, and for those frames, we slowly transition from, we offset it just by a little bit. So that's what this code does. We can just copy and paste it. It's just this just takes care of it. Instead of jumping directly to year to year plus 5, we divide the transition, divide the GDP and the life expectancy by 15, and then add it slowly to the offset. So that way we don't have this effect, and we had, yeah.
Guys, it is basic interpolation. Like you have to go from A to B. All you do is
yeah.
along x-axis and y-axis. You just linearly divide it into pieces, into small changes. And so you end up simulating a smooth transition. The human eye looks at what? There's a certain number of frames per second. So that if you have that many frames per second, then the human eye will perceive it as continuous motion. So all you need to do for smooth transition is pack a lot more frames. And what is it? I think 30 frames per second or 15 frames per second. There are certain limits per second. 12 frames, yeah. Anything over 12 frames, the human eye will perceive it as smooth motion. So movies are like that, right? And if you get a video camera these days, typically they go at 30 frames per second. And for slow motion, they can capture it at 60 frames per second and play it at 30. You get slow motion and all that. So this is a little bit about videography.
There are YouTube, if you check, people have these things with 4,000 things per second. And then they show like bullets going.
Yes, yes, high speed
It's
photography.
very interesting to see that, the way that it
Explodes and goes, yeah, definitely. Or a drop of milk falls
Yes,
into milk. So, yeah. So this is that, guys. This code will look a little bit complicated. We'll give it to you, but if you study it, you'll realize that all it is doing is interpolating the frame, creating in between frames through interpolation, linear interpolation. So, Kyle, could you please paste the whole thing, or what? Okay, paste the whole thing.
Copy some of
Beginning
this.
to end.
I think you can just paste this whole
The entire thing.
cell. Yeah.
Since you're running it, I'll do the copy paste since you're
Okay.
busy.
Let's do that.
And
So when
we
you
also set the title to the center of the plot, so that it looks similar to the Gapminder, the visualization we saw. And we increase the size to 200 and set the opacity to 0.1 so that it has the watermark effect.
There's this
And
1982, the year is being shown in the center of the graph like a watermark. That's what it's doing. So folks, I know it's been a journey, and this is the first simulation we are doing. So you're struggling with your environment. Sooner or later, you'll get your environment fixed. So the first visualization of any kind like this is a struggle with the machine and the software libraries. This is the reality of open source. Once you get it right, I hope you realize that now the next animation you create will be much easier. Would you agree? And we haven't exactly reproduced the Gapminder, but we have come pretty close. Would you agree, guys? We have captured the essence of that visualization.
Yeah.
Anyone? Any feedback? Any comments?
Very nice.
Yes.
Looks
Very,
sweet.
very good.
Yeah.
Yeah. In the space of an hour or so, we have done that. The one thing it's lacking is interactivity. And now Kyle is going to help you with that.
yes, so far we've created a video. So this we cannot actually pause anywhere or get more information, like how we get with interactive charts with Altair and Plotly. So that would be more informative and useful to add to Jupyter Notebook. So now we will learn how to create that with Altair. So if you've already played with the scatter plot with Altair Notebook, we've already covered most of what is covered here. So we start with alt.chart, and we pass in the data set to the chart object, and then we use the mark circle method because we want to plot, we want a scatter plot. Then next we encode, so we mark, we want the X values to be GDP per cap and Y values to be life expectancy. And similar to what we did with matplotlib, we make sure that the scale is of logarithm type and of base 10. You can even use base 2, like how it is in the Gapminder dataset, but here we use 10. Then yes, alt.y, we set y to life expectancy and scale this way. Next, size, we use population. We make sure that the legend is also shown, and make the title to population instead of just pop. Then we set the color to continent and tooltip to country. So, and then here are some properties that we adjust. We want the height of the chart, width of the chart, and the title of the chart, and the year. So once we do all that, we should see a chart like this. It is interactive. Of course, there's so much we can improve upon this a lot more. But for now, you should see something like this once you run this cell.
Let's all do that, please. And guys, remember, this is the scatter plot that we are absolutely nothing new. This is exactly the Altair scatter plot we did last week. Except that, of course, the data, underlying data has changed, but absolutely nothing new. The only new thing is the scale. X-axis has developed a logarithmic scale. Other than that, everything else is what you should, by now, if you have reviewed the notebooks, Jupyter notebooks, this whole thing should look very familiar to you now.
And we said 0 to false because otherwise the Y scale starts from 0. We don't want that. We want it to start from, say, somewhere from 35 to 80. It chooses by itself. So we set 0 to false.
How to set any specific link for a life expectancy instead of like a 10-year or 15 years?
Sorry?
How to set up a life expectancy to a specific limit?
No, it picks the minimum. See, when you set the scale 0 is what, it basically starts with, for this is 1982 data, one particular year's data. What it has done is pick the minima in that, and it found out that the smallest life expectancy of a country was 35, right, or something like that. And so it picked that judiciously. If you make 0 is equal to true, then it will start its.
Oh, thanks. Yeah, because the original plot, it is showing like some of the areas, like if you go back, it was going below 20 and all that.
Yes, yes. That was for, remember, that for the 1800s, right? That is true. But in the Gapminder. But by the time you come to 1982, most of the countries are exposed to modern medicine. So the life expectancies have climbed up.
So as the year, basically you increase the life expectancy.
Yeah, in this case now we just arbitrarily took a year, because the way the approach we are doing is, let's first draw one frame of 1 year and then bring in this year dimension by doing an animation.
Okay.
So,
can we move forward?
Yes. So guys, are we all here? This is just running a cell that we gave it.
Still typing. Oh, she already gave it. I was just copying it from here.
No, you can just copy it. All right, let's move forward.
Do you want me to copy?
Yes, yes.
Yeah,
please.
could you please?
Okay. I just want the official
Thank
go
you.
ahead before I do that.
Yes.
So we see that with Altair, the legends are already there. We don't have to work too much for it. we have two legends, one for the colors and one for the sizes. So it's pretty informative. So next, what we could do is, first of all, increase the size of these points because they are too small. The default scaling for the size is not appropriate, so we will change that. So now what we do is we find out the minimum of population minimum and population maximum. We find that, and we just add this one line after for size. We just add this part. We add a scale to the size. So we set the domain to pop minimum and pop max, and we set the range to something arbitrary. This was also a trial and error method. So once we set that, there's nothing else that I've changed in this cell. So you can just type this out.
One second. What you're basically domain and range words that are mathematical. See, whenever you have a function, y is function of x, the range of values of x is called the domain of the function. The range of values that you want y to take in response as a fx after that is called the range. Now, when it is linear, you're basically saying, let's say that I have a domain, I'll take an example from 1 to 100, but you want the value to scale out and go from, let's say, 50 to 10,000. So what will you do? 1 should map to 50 and 100 should map to 10,000, right? And unless you have a reason to, you would do a linear scaling, that a linear mapping from domain to range, right? Which is what this function does.
So the pop minimum is 2 and the
Yes.
maximum is 8.
No. The population minimum is not 2. The population minimum is whatever it is in thousands of people, and population maximum is whatever it is, but it will be in 100,000s or something like that. But what you have done is you have compressed the range of bubble sizes. Otherwise, tiny bubbles disappear, right? So you have scaled it down. You're saying minimum because visually you can't see a point whose size is below 2. It becomes harder to see. Not you won't see. Harder to see, and then 8,000 is becoming too big, right?
Now,
After
how
that,
does
it would say.
figure out how to assign the sizes of.
No, domain is of course from the data. The range is actually your copy.
Right, but the thing is, how does it, in the scale of it,
Yeah.
how does it decide, like, so this problem I had quite a lot.
By area, by
maximum.
square root. So see what happens is that the bubble's size is area,
Right.
right? And so if you think of it as a radius,
Right.
radius is, let's forgetting pi, is the square root of radius.
Right.
So you basically think in your mind that suppose you have 8,000, right? What is the square root of 8,000? Approximately 90.
Okay.
Right? 81,000, 90, right? So you're saying that my scale is from 1.4 to 90, which looks reasonable because it is still within an order of magnitude.
Correct.
And you should always see, if you want to visually compare things, try to keep it within an order of magnitude, right? So the radius now goes from 1.4 to approximately 90. We could have made it 100 or something.
Right.
For example, she could have made it 10,000. It would still work. Now, so that is the way to go about it when you make visualizations. Don't go beyond an order of magnitude.
Right.
But an order of magnitude to our eyes, we easily compare and contrast, right? So that is one sort of a heuristic you can carry.
So is there another way which converts that to log? So if the range is quite big, not the range, the actual values are quite big.
Yeah.
Convert it into a log and say it is log, but show this.
No, the trouble with log is, see, if you look at the, anyway, I don't want to screen share.
Yes.
Log function goes like this. So what it will mean is that small values will be very small. In fact, a log of, so anything, right?
I tried that, like what Sachin said, I did try that, set the type to log. If you do try that, what happens is all the sizes become very similar. All the,
I see.
so
It's a compressive
India,
function.
yeah.
See, if you look at a log function, it goes like this. What is it doing? It's squashing. It's squashing the thing. So log is somewhat like a squashing function. You don't want to use that.
Yeah, this was very hard for me to get a balance of feed forward. It was like either it was too big or now I kind of play with it.
Yeah. So this is Kyle's choice, and I think it's a good choice. She has made a very good choice just by trial and error. But if you want to remember heuristics that I apply, I say that the ratio of radiuses should be one order of magnitude. Right. So you can go for, as two, sorry, not two, at most two, never go to three. It becomes hard to see. Go up to two, 1 to 100 is fine. One. Okay. 2 orders of magnitude, that's it.
And there is a error. Running, but I am seeing an error over there. I hope others will also get it. Expression cannot contain assignment, perhaps you mean equal to for domain equal to.
No, shouldn't. This should
I
be.
am also getting an error on the first plot of Altair. It's you know,
We
the very
repasted. I was
first.
trying to encode it as code, and it's doing strange things in Slack.
Oh, it's the Slack. Please wrap it up in a code segment. It's the way it was pasted. Yeah, okay, so we can fix that.
So did you paste both the cells together, Kate, the first time?
Well, it looks like, you know, when I click on the, you know, code thing and then I paste, I'm concerned that it looks like it's only encoding the top line, and I want to try to wrap the whole thing, but.
Right, but it worked. The way you had it before, it was still working, even though just first line looks.
I went back to how I did it before. I clicked on the Slack thing for code, then pasted, and then just sent.
And this is just the first cell of Altair,
just the first
right?
Altair cell, yeah. Okay. I haven't done the ones for scale or tooltips yet.
Okay.
Yeah.
All right, guys, are we over the errors? Sachin, is that fixed now?
No, for me it was like got the actual file from.
Okay, you of course. And it works, right?
No, it doesn't work.
Oh, it doesn't work.
Unless like there's some plotly thing to be updated.
No, not partly. This is Altair.
Altair, right? So
go run the installation again till the visualization install. Run that file again. You may not have updated the library. All right, guys, are we all here? Now, does it begin to look closer to the visualization? Forget the legend part. But
yes.
Is it beginning to
now
look
we will yeah, we will clean up the legend right now. So this information is actually overpowering what we want to show. This population is just we can visually see it, so we don't need this legend here. Instead, we could show it as a tooltip. So that's what we do next.
But can we first, can you paste the code for the one above? We were still on the very first plotting with Altair, the very first Altair
Let
plot.
me give you the, I'll give you the one for scale.
Yes.
Yes, please.
Let me give you the one for scale.
Thank you.
All right. And now let's run it, guys. So we are giving, actually, I didn't plan for it to take up all morning, but it seems to be, this is a landmark visualization. We need to get it done. It's important. And I hope you'll feel good about it once you finish.
Okay, the scale cell is now in Slack.
Can we move forward, guys? Huh?
Yeah, it works.
Yes.
Thank you, Kate.
Good. So now let's see how she adds tooltips and subtracts some certain ones.
So here, we don't want the legend for the size. So what we say is that legend equals none. Then we remove the legend that way. Then we add tooltips. So here we want to show two things. We want to show the country as well as the population. So we create two tooltips. So one is the country, and we set its title to country, and tooltip population, and we use this format. So this format, I've also there is a link here. You can look up D3 formats.
There's a comma missing after pop min. on that scale equal alt dot scale domain equal pop min pop max, about in the middle of the cell. Go like 3 lines above the legend. No, yeah. move
Okay,
down.
okay. Yeah.
Right. Pop min does not have a comma after it. I think that's
Oh,
line 19.
yeah.
Yeah, that's right.
Yeah.
Oh, God. Yes.
Thank you. Okay, so I did get an error. Run this cell. Yeah. Now it's good. So
So copy
you
the
can look
entire
up the
thing here.
formatting.
Yes.
You can learn more about formattings. You can format it with percentages in different methods. Here we want these commas so that we get an idea, get a sense of the population. So you can see the format in action here. So that's that, and we set the title to population, and the rest is the same. So we remove the legend and add tooltips in this cell.
The code is in Slack.
So the comma is for putting it like.
Just number formatting. When,
Yeah.
It's basic number formatting for readability.
Okay, so can we move forward?
Yes, let's move forward.
Okay, so then we just add titles. So here we haven't formatted anything. So we change the title, we change the x-axis labeling, y-axis labeling, and also change the legend label, legend title. So
Yeah, so small improvements, guys.
Yes,
Small
small
improvements to
improvements.
make it better. Just small changes.
and so now it looks much better. Then finally we are going to use dynamic data. And okay, so here just as we did with scatterplot notebook, we're going to use something called a selector, and we're going to bind that selector to our chart. So the first thing we do is we create a slider. We want the slider to show years between 1952 and 2007, and we want it to have a step of 5. So we want 1952, 1957, and so on. Now we bind this slider to
Then
a
why did
selector.
you take a step of 5? Why not 1? So that
Because
people can plot at any given.
But the data has only 1952 and 1957. It doesn't
Oh, that's
for
right.
every 5 years.
It's every 5 years. Yes.
Yeah.
Nice.
So once we do that, we bind this slider to our selector. So Altair has different types of selections. One is single select, selection single, selection multi, and selection interval. So here we use selection single. Selection interval selects a particular range. Selection multi selects multiple things, but here we want just to select one item, and that is we want to select the year from the slider, right? So that is stored in this selector object. And what we do is we don't change anything from the code. We already formatted everything we want from the previous cells. We just copy and paste the whole thing. The only thing we add are these 2 lines in the end. One is add selection and transform filter. So add selection, first of all, binds this selector object to our chart. So now the selector object is available in our chart. And secondly, we do this transform filter. There are many methods: transform, calculate, transform window, and many more. But transform filter, it basically filters the data based on the selector. So we already specified in the selector that we are going to select from whatever data set is available in our chart. We want to filter based on this particular column here, and initially we set it to 1982. So our chart will initially show us the data of 1982. But then we can change it later on. So all we do is we add these 2 lines in the end, and we add a slider and we add a selector. So, and once we do that, now our chart has become interactive. So here we have a slider. So we can change, we can slide back and forth. And we can pause anywhere we want. We can get more information on each bubble, just like in the Gapminder data set. You can even play with it even more, so that when you, just like in Gapminder, we could, once we clicked on a particular bubble, everything else was grayed out, and just that particular bubble was alone, it had its color. So similarly, that is also possible. So you can try that out as an exercise. You can improve on this code. And I hope you all reached this point for now.
Yes, let's move forward from this.
Okay. And finally, we're just going to customize a little bit more. We see that as we move here, our y-axis limit keeps changing and our x-axis limit also keeps changing here. So we don't want that. We want it to be quite stationary. So we
Flipping
just
around,
change.
basically.
Yeah. Yeah. So we just set the x-axis limit in our scales. So we fix the domain, right? So we fix the domain for both x and y. And once that is done, we just add a little bit of more styling. We add some strokes so that when bubbles overlap, we know exactly how they overlap. So once that is done, let's run this cell. It should, okay, it's run. So now we don't have that effect. We don't see the bubbles flipping around, and it's
a good place to stop with that here.
Yep, yep.
Nice. All right, guys. So in the lunch break, I want you, we'll upload the notebook right after this. In the lunch break, take some time and read the code carefully and run it on your machines. You will by now realize that if you have done all the scatterplot notebooks carefully, you are in familiar territory. Everything will look new, but at least if you go back and compare what you have learned in scatterplots, you'll see that all the elements are taken from there. We are not bringing in too many new things to make this happen. Just a little bit here, there, cosmetic changes. And in slow steps, we are building this visualization. Nice, let's move forward.
So, and finally, we could do all this in a single step with Plotly. So Plotly makes it very simple for us. So we just have one cell for Plotly, and this is all we do. This is pretty much basically the same code as before. Probably you don't need it again. You can, you don't have to add this. So with Plotly, if you better import Plotly Express, it's already there in the imports notebook, visualization imports. If not, you can import it separately. That is import Plotly dot express as tx. So that should work. Then so here we do a scatter plot, we pass in the data, everything is similar. So it's just the syntax is very simple here. X equals, and then log x, we want the scale to be log x, so we just say log x equals true. And then our y, and what should be the domain. Here they call it range. In Altair it was called domain. So but then we set the range of x and y, and then we set the size. We set what our maximum size should be. We don't manipulate too much, and set the color, and then we set a particular color map. We set what do we want as our tooltips, and so this is the only thing. So now here with Altair, we didn't have any animation, we couldn't play anything, but we could move around with the slider. With Plotly, animation is just very simple and comes just in 2 lines. So we want the animation frame to be based on year, as in for each frame, we want to group the data frame by year, right? So that's how we do this. Second is animation group. So we want each country to look very continuous. So from the previous year to the next year, we want the country to move very smoothly. So the bubble of each country should move very smoothly. So
Very nice. So guys, here's the thing. Do you notice that Plotly here excels in this thing? And obviously, if you look at the
for that
documentation,
we use animation group and set that to country. So country is
the thing is, thank you. So guys, you notice that Plot makes it very easy. So the people who are making the Plotly library, they actually paid attention because they obviously that library was created after the Wealth of Nations visualization, Gapminder visualization was there. And so they asked this question, what is missing? What can make it very simple to create such a visualization? And they literally made them as arguments to this scatter function itself, because ultimately it's a scatter plot. And that's the beauty of it.
so, and that's it. So it's very simple.
You like to run
Very
it?
few lines of code, and let's run this. So, okay, it's gonna take a little bit of time. Oh, it's done. So it's very neat. We have everything well made, and we can run this as an animation. And also use it as a slider, just as we saw in our Gapminder on the Gapminder website. It's possible, and we get all the information in the tooltips. So
Very well done, Kyle. Thank you.
yeah,
Yeah.
and that's
So
that.
very well done. So guys, we are going to take a small break, then we're going to do line plots. But before we do that, guys, I hope by now you realize that never underestimate the power of simple visualization elements like bar charts or scatter plots. People, whenever they think of bar plot, they will just do a plot bar, right? Or something like that, one line, and they get a basic visualization. The whole point of visualization is to tell stories with data. Find what's hidden there in the data, what the real story the data is trying to tell, and tell that story. Create very compelling visualizations, right? And that has to be the goal. And if you notice it, these things, when you go and look at it, you realize that these simple elements, they have sort of hidden superpowers in them, whether it's the bars or the scatter plots and so forth. And I hope you will harness them to the maximum. Now, what we will do is we're going to upload this. I'm going to upload this visualization library to the course website. You can download it. You can play around with it. Don't do it now. At this moment, we'll move on to the line plot. Kyle, would you like to do the line?